All right, so what if we have an absolute value function? So we already know we get a d and e at our 5 here because this is an absolute value. So they're approaching left and right. Our slopes would be -1 and +1, d and e. So we already know that's our critical number. But let's show it using derivative as well. So if we take our absolute value of x minus 5 and we'll replace it with the square root of x minus 5 squared, this would also give us an absolute value. The square will, when it's being squared, we'll take any number in there and turn it into a positive, and then the square root will convert it back to the positive version of it, like an absolute value does. So we end up with f of x equals x minus 5 squared, bracket, to the 1/2. And so now we can apply chain rule. And so the inside here that we have is x minus 5 squared. So when we take the derivative, we would end up with 1/2, bracket, x minus 5 squared to the -1/2. And then this would become 2x minus 5. So we tack that on over here. So now the 2's cancel. The 2½ cancels. And then that one will go to the bottom. So we end up with f prime of x equals x minus 5 over x minus 5 squared to the 1/2. And we already know that this is this, which is absolute value of this. So we can now rewrite it as x minus 5 over absolute value of x minus 5. And so you can see we are now getting a d and e, oops, let's put that as 0, a d and e at x equals 5. And so there's our critical number. And so now we need our critical point. So if we plug 5 into the original function, we end up with 0. So we do have a critical point of 5, 0. So now under what intervals is it increasing and decreasing? And we already know how this looks. This is an absolute value. So it's going to be, let's change this to blue, 5. It's going to be decreasing, so that'll come out to be negative, and then it will be increasing, so that'll come out to be positive. So if we test this, right, with our derivative, right there, f prime of -100 and f prime of 100. So if we plug that into our x minus 5 over the absolute value of x minus 5, let's see what happens. So this is -100 minus 5 over positive. So you can see that's negative over positive. And I got that because it's an absolute value. And that comes out to be negative. And then if we plug in our 100, this would come out to be 100 minus 5 over positive, which again is positive over positive, and we're increasing. So it's increasing from 5 to infinity and decreasing from -infinity to 5. Those are our critical numbers. And yeah, you could just have drawn a graph of this and said, oh, my critical number is at 5. But at least we have the algebra behind it too. Well, the calculus. All right, so we have a relative max or a min. So again, this would only be no maximum, none. And we have a relative min at 5 of 0. So x equals 5. And that would also become a maximum as well. And there is no maximum because our graph is just doing this. It's coming in, going out, and so that's our min. And there you have our absolute value.